Elementary Algebra 8.3a, addition and subtraction of radical expressions. Okay, we did multiplication and division first because those are the easiest. Now, usually it seems like multiplication and division is the harder. I mean, when you're in elementary school, you learn your pluses and minuses. Then you do multiplication and division. But when you're in algebra, the addition and subtraction seems to be a little bit harder, especially when you're dealing with radicals. Because, and I had mentioned this earlier, a couple lessons ago possibly, that when you have a radical and another radical, if they're the same, you can add them together. You kind of look at a radical as being like an x. X plus x is 2x. Square root of 5 plus the square root of 5 is 2 square root of 5s. Okay? If I have x plus y, I can't add those together. It's not possible because x and y have to be the same variable in order to add them. The same is true with radicals. If I have something like that, I cannot add those together. Okay? So I have two options. In some cases, like this one, square root of 3 plus 2, you can't do anything with. You just say, sorry, can't do it, I'm done. All right. The other option with some numbers, and that's what we'll get into today, is you can simplify them and then possibly add them together. So, for example, square root of 2 plus the square root of 8. You're like, nope, can't add those together, I'm done. But no, wait a minute, we can simplify that. This can be simplified to 2 cubed, right? 2 times 2 is 4 times 2 is 8. So, this is a 2 right here, correct? How many times does 2 go into 3? Once, with 1 left over. So the square root of 8 can be simplified to that. And lo and behold, what's the radical? The square root of 2. So now I can combine these because the numbers underneath the radical are the same. And not only that, the indexes are the same. So what is 1 square root of 2 plus 2 square root of 2's? 3 square root of 2. So therefore, I can add these because I can simplify this one down to having a square root of 2. All right, so that's what we're going to get into, is how to recognize and do all of those. So if I had something like 3, whoops, get my pen working. The indexes are the same, meaning the number that is right in here and right in here, it's assumed 2 because it's not there, and the number inside the radical is the same. Therefore, you can combine these. So you just look at the numbers outside. 3 minus 4 is negative 1, and then you'll always tag this on there. Okay? So that's what you end up getting. Now, you don't have to write it this way with this 1 here. Whenever there's a 1, it's just an assumed one, so you can just leave it off if you want. Just get the square root of 5. You can leave it there if you want, but it doesn't have to be there. Okay, so let's get started on doing some of this fun. So, told you the rules, and now that you know the rules, let's jump into doing some of these. Alright, so we have 7 square root of 2. This is example 2. Alright, all the radicals are the same. All the indexes are the same. You know, the numbers that go here, here, and here. So that being the case, our answer is going to have the square root of 2 in it. And all we're concerned about is those numbers. 7 minus 3 is 4, plus 6 is 10. And you just added them. Okay? Wouldn't it be great if that's as hard as it got? But it never is it? I never just let you have that being as hard as it gets. I always got to make life more miserable for you, don't I? All right. Well, let's keep going into the misery. 6 square root of 5. See, I put red on there for blood because you're going to be sweating blood doing these hard problems. Okay. Now, what do we have? We have a 6 square root of 5 here and a square root of 5 there, but I don't have one there. So that means that I can combine this one and I can combine that one, but that 5 square root of 2 you can't do anything with, so we just tag it on when we're done. So 6 minus 3 and then 5 square root of 2. That is all I can do. I'm done at that point because these are different, so they can't combine. So I simplify it as much as I can, but that is pretty much all I can do. All right, so let's see here. Let's go to example 4. Now remember what I had said earlier, that sometimes, whoa, that doesn't look like a 50. Sometimes I get something like that. Now, the numbers under the radical are different. I cannot add them, but what I'm going to do is I'm going to try to simplify each one of them to see if I can get the number under the radical the same. So I'm going to do square root of 25 times 2. Remember, two numbers multiplied together give me 50 that I can take the square root of 1. That's what I'm looking for. And this will be 16 times 2. And I can take the square root of 16, so I like that one. Alright, so square root of 25 is 5. And then the square root of 2 stays in there because that can't be simplified anymore. Square root of 16 is 4. And square root of 2 stays in there. Alright, so I get 15 square root of 2 plus 8 square root of 2. Okay, lo and behold, my radicals are the same now. I can add those. 23 square root of 2. And that's a lot easier. Alright, so let's keep plugging away. Alright, so I've got these doggone indexes that are 3's. So cubed roots here. So, there's not a number I can multiply by itself 3 times to get 375. There's not a number I can multiply 3 times to get 81. There's not a number I can multiply by itself 3 times to get the square root of 3. So, that makes it a little harder, because that's always the first step, because it'll make life better. So now what I'm going to have to do is I'm just going to have to simplify each one of these. This is already simplified. It's already a prime number, so I can't do anything with the 3. So let's look at 375. Let's see. Are there two numbers I can multiply together to get 375 that I can take the cubed root of one of them? And I know that I can take, and you just have to try a bunch of numbers. Okay? Two numbers multiplied to get 375 that you can take the cubed root of. And I find that it's 125 times 3. 125 times 3 is 375. 5 times 5 times 5 gives me 125. So this number I can take the cubed root of. So that's why I picked it. Oops. Okay, so let's see if I can get my stuff back. Alright, so I'm going to write this as 125 times 3. And let's just get rid of that for now. And 81, what can that be written as? Are there two numbers, 27 and 3, okay, where I can take the cubed root of that, okay, minus 6 cubed root of 3. I can't do anything with that thing. Alright, so let's look at this. What is the cubed root of 125? We said it was 5. And we still have the cubed root of 3 in there. So this pulled out because we can take the cubed root of that. Cubed root of 27 is 3, and that cubed root stays in there. And this cubed root of 3 stays in there. So, lo and behold, cubed root of 3, cubed root of 3, cubed root of 3, which means that I can put my 5, 3, and 6 together. 5 plus 3 is 8, minus 6 is 2. And that's what my answer is when I simplify that. Okay? Alright, let's keep going here. Kind of pause there for a minute as I'm trying to think, is there something I missed, something I need to explain better? And like I say, it's hard. It's just going to take practice. This stuff can be pretty complicated and pretty hard to get a hold of because there's just so much to learn. Okay, so let's look at our first one. Obviously, we can't combine these because one has a 12 and one has a 3a squared. So we're going to say, are there two numbers multiplied together that give me 12? No. Are there two numbers multiplied together give me 12 that I can take the square root of because my index is a 2 there? Yes. 4 times 3 because I can take the square root of 4, and that's a happy time. Okay, and let's just leave this all the same right now. Alright, so the square root of 4 is 2, so I'm going to bring the 2 out here with the a, and I'm left with the square root of 3. Now I've got a 5. Now, I'm going to look at my variable. I have a 2 here, so 2 goes into 2 one time, so I can bring the a out, so that goes away, and I'm left with a 3. Okay, radicands are the same, indexes are the same, that means I can add what's outside. Okay, and I am done with that one. Alright, let's jump to example 7. Alright, so we're going to just go through and simplify what's in each of these radicals, one bit at a time. So let's look at the 20. So, are there two numbers multiplied together that give, or is there a number multiplied together that gives me 20? No, there's no square root of 20. So are there two numbers I can multiply together and get 20 that I can take the square root of one of them? Yes, 4 times 5, because I can take the square root of the 4. So that's what I'm going to use. Minus 3x. Two numbers multiplied together give me 45 and take the square root of one of them, 9 and 5. Alright, square root of 25x squared. Is there two numbers multiplied together give me 25? Yes. 5 times 5. So I can just take the square root of that eventually. Alright, so we're going to take the square root of 4. And the 5x cubed will stay in there for right now. Square root of 9. 3 comes out. And square root of 25. Alright, so let's just rewrite this. Alright, what do you notice here? I still can't combine these because the numbers under here aren't the same. I mean, this is a 5. Oops, this one here, I got to put a square root sign, sorry. This one is a 5x cubed, that's a 5x, and that's an x squared. So I can't do anything yet. Alright, well, let's keep going. So, remember, this is a 2 here. My index is 2. So how many times does 2 go into 3? Once. So I pull 1x out, and I'm left with the 5, and I'm left with 1. Okay, 2 goes into 3 one time with 1 left over, and there's my 1 left over. This doesn't have any exponent, so when you don't have any exponent, it just stays the way it is. You can't factor it if there's no exponent. I promise. And 52 goes into 2 one time, so we can bring 1x out, and there's nothing left in there, so that's done. Alright, so now where are we? 2 minus 9x is negative 7x square root of 5x plus, it takes care of that, 50x, which I cannot add because I don't have the same numbers under the radical. That means I'm done with that one. Alright, one more example and then we're done. Okay, so we're going to simplify. We're going to simplify this. Two numbers multiplied together give me 12 that I can take the square root of one of them. And so that gives me 6 plus, square root of 4 is 2, square root of 3 I don't know, so it stays in there. That comes out. Now I'm going to look at this and see if I can take anything out, and I can take a 2 out, and I've got that left over, and that's over 4. Okay, so far not bad. That 2 cancels with that. 2 over 4 is 1/2. And I don't need that 1. So there's my answer. 3 plus square root of 3 over 2. And I'm done with that. Now again, I did it a lot different than the book does, but still works well. Alright, problem set 8.3 in the next video.